Hello students, in this video we will continue our discussion on the chapter relation and function. Today we will discuss about solution of exercise 2.2. This exercise depends on the topic relation. So let us start with question number 1. Let A is a set containing 1, 2, 3, 4 up to 14. Define a relation R from A to A by R where the relation between first and second element is R is a relation containing ordered pair xy, where the relation between first and second element is 3 into first element minus second element is equal to 0. Okay. So, what is the relation between first and second element of the ordered pair? 3 times of first element minus second element is equal to 0. Write down its domain, codomain and range. First of all, this relation set is given in set builder form. You have to change it in roster form. Okay. Now, the relation is from A to A. That means the element from x and y can be from 1 to 14. Now, from 1 to 14 we will check which value of x and y satisfy this equation. Okay. Now, if you consider, you can write this equation as 3x minus y equal to 0, and here you can write 3x is equal to y. That means the second element have to be 3 times of the first element to satisfy this relation. Okay. So, what is the condition? The second element have to be 3 times of the first element. That means, if you take first element as 1, second element will be 3 times of 1, that is 3. If you take x equal to 2, 3 times of 2 will be 6. This will be another order pair. Then 3, 9. Then 4, 12. But when you are taking x equal to 5, y will become 15, and as you can see, this 15 does not belongs to set A, right. So, our set will contain, our relation set will contain 4 element, these 4 ordered pair. Okay. So, the roster form of given R is collection of 1, 3, 2, 6, 3, 9 and 4, 12. Okay. Now, you have to write the domain, codomain and range. Domain is the set of collection of first element of the ordered pair. First element is 1, 2, 3, 4. So, domain of R will be set 1, 2, 3, 4. Now, range is the collection of second element of the ordered pair, and second elements are 3, 6, 9, 12. So, range is the collection of the element 3, 6, 9, 12. Now, codomain. R is the relation from A to A, right. I told you the second set is considered as codomain, where the image of each element of R goes is called the is considered as second set. Okay. This R is the relation from A to A, means from the definition R is the subset of A cross A. This second set is considered as codomain. So, codomain will be set A. Now, question number 2, define the relation R on the set N of natural number by relation set is given as ordered pair x and y, where the relation between first and second element is y is equal to x plus 5. That means, second element is equal to first element plus 5, and the value of x have to be less than 4. Okay. Value of x have to be natural number and less than 4. So, the option of x is 1, 2 and 3. Okay. Now, when x equals to 1, when x equals to 1, the value of y will be 1 plus x, that is 6. When x equal to 2, the value of y will be 2 plus 5, that is 7. When x equal to 3, the value of y will be 3 plus 5, that is 8. You get the value of y by this relation. Okay. So, the ordered pair will be 1, 6, 2, 7 and 3, 8. So, the relation set R in roster form will be 1, 6, 2, 7, 3, 8. Now, again you have to write the domain and range. Domain is the collection of first element, that is the collection of 1 to 3. Okay. Domain is the set containing 1, 2, 3, and range will be the set containing the second element 6, 7 and 8. Okay. And this way you have to solve question number 2. Now, question number 3. A set is the collection of 1, 2, 3, 5 and B set is the collection of 4, 6, 9. Define a relation R from A to B by, the relation is difference between first element and second element is odd. So, you have to form the ordered pair in such way that the difference between x and y be odd number. So, suppose okay, first of all, if you subtract even from even number, the value will be even, that is the subtraction of two even number is even. So, you cannot take the ordered pair of two even numbers, right. Similarly, if you subtract odd from odd, again you will get even number. So, you cannot subtract even minus even because the resulting will be even. Similarly, odd minus odd is also even. So, you cannot choose this type of ordered pair. That means, two element of the ordered pair cannot be even, or two number of ordered or two element of ordered pair cannot be odd. Clear? So, if you take first element have to be from A and second element have to be from B. So, if you take first element 1, second element you can write as 4 because 1 minus 4 is equal to minus 3, which is an odd number. Similarly, you can take 1, 6, difference will be 5. Okay. Then you can take, okay, you cannot take 1, 9 because both of them are odd. Now, you can take 2, 9 because 2, 9, the difference between 2, 9 is equal to 7, which is an odd number. Now, you can take 3, 4. So, right here 3, 4, difference will be 1. Then 3, 6, difference will be 3, which is odd number. But you cannot take 3, 9, the difference between 3, 9 is 6. And then you can take 5, 4, difference is 1. 5, 6, difference is 1. But you cannot take 5, 9 because the difference will be 4. So, the collection of the relation set will be 1, 4, 1, 6, 2, 9, 3, 4, 3, 6, 5, 4, 5, 6. Look at here, the difference between these two is 3, these two is 5, these two is 7, these two is 1, here is 3, here the difference is 1, again here the difference is 1. This 3, 5, 7, 3, 1, these all numbers are odd number. In this way, you have to form this relation in roster form. Now, next question. The figure shows a relationship between the set P and Q. Write the relation in set builder form and in roster form. What is its domain and range? As you can see here, 5 goes to 3, 6 goes to 4, 7 goes to 5. Okay. So, when you are writing this relation in roster form, it will be R 5 goes to 3, right. If you take the first one, 5 goes to 3 means 3 is the image of 5. So, the ordered pair will be 5 3, okay. 5 goes to 3. Similarly, 6 4, 4 is the image of 6 and 7 5. So, this will be the set in roster form. Now, you have to write the relation in set builder form. Look at the ordered pair. What is the similarity in the ordered pair? Here the difference between first and second element is 2. Here also the difference is 2. Here also the difference is 2. Okay, that means you can write the second element y will be first element minus 2, right. 3 is equal to 5 minus 2, 4 is equal to 6 minus 2, 5 is equal to 7 minus 2. So, this relation in set builder form will be R is the collection of ordered pair x y, where y is equal to x minus 2, okay, and this x belongs to P and y belongs to Q, okay, where this x belongs to P, okay. So, in this way you have to write it in set builder form. Now, domain. The domain of this relation will be 5 6 7, okay. Now, codomain of this relation will be not codomain, range of this relation will be 3 4 5, okay. The collection of 3 4 5 will be range set and the collection of 5 6 7 will be domain set. Question number 5. Let A is the set collection of 1 2 3 4 6. Let R be the relation on A defined by collection of ordered pair AB, where B is divisible by A. Okay, so again you have to write it in roster form, you have to write domain, you have to write range. Okay, the relation is from A to A, that means the relation is a subset of A cross A. A contains 5 element means this A cross A will contain 25 element. Now, this 25 element will be in the shape of ordered pair, as you know from the Cartesian product, and from this 25 ordered pair you have to choose which ordered pair will satisfy this condition, that is the second is exactly divisible by first element, okay. If you write it in roster form, it will be collection of 1 1 1 2 1 3 1 4 1 6. Look at here, 1 is divisible by 1 2 3 4 6, every number is divisible by 1. Then 2 2 2 4 2 6, 6 4 2 divisible by 2, 3 3 3 6 4 4 6 6, okay. As you can see in this collection, every element, every second element is divisible by the first element, corresponding first element, but you cannot take 2 3. Why? Because this 3 is not divisible by 2, so it will not belongs to relation set, okay. Similarly, you cannot take 3 4 because 4 is not divisible by 3. You cannot take yeah, that much, okay. These two elements does not belongs to the set. Then you cannot take 4 6. This element also does not belongs to R because 6 is not divisible by 4. In this way you have to judge and you have to form the roster form. Now, the domain will be the collection of first element of the ordered pair and the range will be the collection of second element of the ordered pair. Question number 6. Determine the domain and range of the relation defined by relation is first element will be x, second element is x plus 5, where x belongs to 0 1 2 3 4 5. That means the value of x can be any 6 of these numbers. Okay. So, when x equal to 0, the ordered pair will become 0, 0 plus 5, that means 0, 5. When x equal to 1, the ordered pair will be 1, 1 plus 5, that is 1, 6. In this way, when x equal to 3, ordered pair will be 3, 8. For x equal to 4, it will be 4, 9. When x equal to 5, it will be 5, 10. When x equal to 2, it will be 2, 7. Okay. So, the collection of ordered pair will be 0, 5, 0, 5, 1, 6, 2, 7, 3, 8, 4, 9, 5, 10. So, this is the representation of relation set in roster form. Now, you have to find the domain and range. This is very easy. Domain set will contain 0, 1, 2, 3, 4, 5, and range set will contain 5, 6, 7, 8, 9, 10. Okay. Now, question number 7. Write the relation R where first element is x and second element is x cube. That means first element cube. X is prime number less than 10. You have to change it in roster form. Very easy. First of all, you have to judge the prime numbers which are less than 10. The prime numbers which are less than 10 is 2, 3, 5 and 7. So, ordered pair can be, when you are writing 2, it will be 2 cube. When you are writing 3, it will be 3 cube. Second element will be 3 cube. When you are writing 5, second element will be 5 cube. When you are writing 7, second element will be 7 cube. So, the collection is 2, 8, 3, 27, 5, 125, 7, 343. 2 cube is equal to 8. 3 cube is equal to 27. 5 cube is equal to 125. 7 cube is equal to 343. Now, question number 8. Let A is equal to this one, B is equal to this one. Find the number of relation from A to B. Again, I have discussed about this type of question in previous video also. A contains 3 elements, that is cardinality of A is equal to 3. Cardinality of B is equal to 2 because it contains 2 elements. That implies cardinality of A cross B will be 2 into 3 is equal to 6. Now, relation set is subset of A cross B, any subset of A cross B. Right. Now, cardinality of A cross B is given as 6. So, how many possible subset can you form of this A cross B set? It will be 2 to the power 6, and any one of them can be the relation. So, the number of relation will be 2 to the power 6. Now, question number 9. If R be the relation of integer set Z defined by R is equal to A comma B, where A, B belongs to integer and A minus B is an integer, find the domain and range of relation set. Okay, the relation set R will contain those ordered pair where the difference between the first element and second element is an integer. Okay. Now, you know that the difference between any two integer is equal to integer. Difference between any two integer is an integer. So, in the ordered pair, you can write any two integers such as 1, 1, 1, 2, 1, 3 or ... 390 or 90, 390, then 5000, any difference or 5, 9 or 900, okay, you can write dot 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 dot. Any of this means in the ordered pair, in place of first and second element you can choose any two integer and the difference will become an integer, right. That is why the domain can be, the first element can be any integer and the second element can be any integer, right. That is why the domain of the relation R will be integer set and the range of the relation R will be also integer set. This was the last question of the exercise 2.2. This is all for today. Thank you.